and collect like terms, and we can leave it like that. Some people factorised, it was okay. Right, part 2, if we have 2 real roots, then that means we either have 2 distinct solutions, so the discriminant is greater than 0, or 2 repeated solutions, so we're equal to 0. So when does that, when is that greater than or equal to 0? Now this is a quadratic inequality, which means we must factorise first and then draw a Sine diagram. Alright, so my Sine diagram, my critical values are -9 from the first bracket, -1 from the second. If I sub 0, which is over here on the number line, into the equation, I end up with 9 times 1, which is positive. So my signs will alternate. So where are we less than or equal to 0? Sorry, greater than or equal to 0. We are greater than 0 there, equal to here, greater than here, equal to there. So that would be k is less than or equal to -9, or k is greater than or equal to -1. Alright, so this one can be done partly on the calculator, but we can factorise the denominator here into 2 linear factors, x times x, and then we've got 6 and 2, so -6 and +2 would work. And therefore, my critical values are the vertical asymptotes, which are at 6 and -2. Now these are asymptotic and therefore dotted lines. My other critical values will be x-intercepts, which occur when y equals 0, which means when the numerator is 0, which is 1/3, which is somewhere in here. Choose a number other than these. Let's go for 1,000,000 over here. This is positive, that will be positive, everything's positive. There's no repeated factors, and therefore the sign will alternate. So there is your Sine diagram. In number 11, we've got to work out x, y-intercepts. Y-intercept is always easy. That occurs when x equals 0. And if you plug in x equals 0 in here, you end up with -15 and -3, which is +5. Your x-intercepts will occur when y equals 0, which means when the numerator is 0. So 2x squared, etc., which will factorise 2x times by x, and we end up with those factors, and therefore solutions would be +5 on 2, or 2.5, or -3. Now part 2 can be done 2 ways. Some people use long division on the original equation here, dividing x take 3 into that, and that gave you the solution of 2x plus 7, etc. Another way to do it would be to combine these two on a common denominator of x take 3. So you're treating that as being over 1. So you times 2x plus 7 by x take 3. And the +6 is up there as well. Now if you expand the brackets, now collecting like terms, we have 2x squared and we have -x -15, which is what we had to start with here. So there it is. Now, hence means using the previous answer. So we can use this equation here. Some use their solution, which wasn't the same as that, and that's okay, but you should look at what you were given. So now we have an oblique asymptote, y equals 2x plus 7. and the vertical asymptote will be x equals 3. So discussing the behaviour, you could put that into the calculator, and what you will find as x approaches infinity, as x approaches negative infinity, y will approach the oblique asymptote. Now for positive infinity, it will approach from above, and for negative infinity, from below. Then consider what happens as x approaches 3, the vertical asymptote, but we can do it from two directions. So we can do it from the left or from the right. So as we approach from the left, we approach negative infinity and then positive. Once again, you can see that on your calculator. In question 12, we have to use these bits of information here. So first up, f of 0 means put 0 in place of x. So you put 0 there, you put 0 there, you're left with c. And therefore c must equal 9. Now f of minus 1. Put the minus 1 in place of x, we end up with plus a minus b plus c, and that is all equal to 12, which can then be rewritten as a take b equals 3. Now do the same for f of 3, which gives us that, and therefore that must be the same as the value of f of 3, which we were told is 24. Simplify that, and we'd end up with 15 dividing by 3, we get 3a plus b equals 5. So equation number 1 and equation number 2 can be solved simultaneously, and we end up with values, in this case using the calculator, of 2, negative 1, and we knew that c was equal to 9. Part 1, we are given the area, and therefore we should be using the area formula. The area is equal to a half BC sine A. So in this case, a half x times 14.9 sine 76. And all of that now is equal to the value of 56. We can make x the subject. That 2 will multiply across here, so 2 times 56, then the 14 sine 76, they will both divide into the numerator. And throw that into the calculator to get an answer of 7.75 centimetres. Right, next question. There's a few ways to do it. Some of you did it using Year 10 trig, using the right angle triangle here and the triangle there. I'm going to work out this length here first up, y, and then I'm going to use this triangle here in order to work out DE. It does require this angle here, plus this one here, is equal to 39. That's the exterior angle of the triangle. So we end up with this angle here being 14 degrees. So to work out y, we can use this triangle here, we can use the sine of 39 equals 21 on y. And rearrange the equation, we end up with 37 centimetres for y. And now to work out DE, I know that DE on the sine of 14 is equal to y on the sine of 25. So DE would equal y times the sine of 14, all divided by the sine of 25. So this number, 33.37, throw it into the calculator, times by sine 14, etc. And you end up with about 19.10 centimetres. Now in this one here, we either use the cosine rule or the sine rule. For cosine rule, I need either 3 lengths, which I don't have, or 2 lengths and an angle between, which I don't. The sine rule, I need a length and the angle opposite, length and the missing angle. I could use sine rule to find x. So the sine of x over 52 is equal to the sine of 56 over 61. Rearrange gives us this, and when we work out the sine of x, we will get a positive value, which means that the inverse of sine will give us 2 possible values. We've got the ambiguous case, so 44.97 or 135. Which is too big? If you add that 56, you're over 180 degrees. So you should check to see if it is possible. In this case, it's not. Now, given x, we can work out the value of y, and we can do that using the sine rule. So I can work out this missing angle here, which I'll call theta. Which gives us 79.03. So now, in order to work out y, we have y on sine theta equals 61 on sine 56. And rearrange that, we end up with a value of y being 72.24 centimetres. In part 2, I have 2 lengths angle between, which is ideal for the cosine rule. So I can work out x. So x squared equals 5.5 squared root 13 squared, which is 13. 2 times by 5.5